my previous videos, we talked about the power rule. Actually, we spent a lot of time on deriving and looking at the power rule very precisely. And now we want to write some other rules for integration. Guys, there's so many of them. I'm not going to write all of them. You can find them in your formula sheets or you can find them in your textbooks. So please look back in your textbooks and formula sheets to see those formulas. So here I want to talk about 4 of those important formulas that will show up when we start solving examples. Guys, the first one is going to be the integral of x to the power -1 with respect to dx. So we already know that when there's an exponent, when n is -1, we cannot directly use the power rule. So to do something like this, what we have to do is we have there's few different ways. One of the ways is to kind of think about the reverse process, like what is the derivative, because we know that the derivative and antiderivatives are the reverse of each other. So looking at the derivatives, we know that this is ln of x plus c. Why? Because the derivative of ln of x, the natural logarithm of x, is 1 over x. So we know it's the reverse process, so that's how we are able to actually write this. And of course there's going to be a plus c. Then the second one is, what is the integral of e to the x dx? And guys, this is pretty simple as well. It is just e to the x plus c. I mean, exponential function is one of the easiest and one of the best functions, because the derivatives of the exponential function of the form e to the x is e to the x, and the antiderivative is the same. Okay, and again, you can just quickly verify this. What is the derivative of e to the x plus c? The derivative of e to the x is e to the x. Derivative of c is constant, is 0, so you get back this, right? So this works. Then the third one is, what is the integral of something of the form b to the power x, where b could be anything. It could be e, it could be any other number. So in that case, it is b to the power x divided by ln of b. It is a little more, there's some extra stuff here compared to this simple exponential function of the form e, and then there's a plus c. And again, it's not too difficult to kind of convince ourselves that this actually is true, because you can just start looking at this function and try to find the derivative of this and see if we get back b to the x. So let's try doing this one actually. So if I have to find the derivative of this, guys, keep in mind ln of b is a constant, so I can just take it outside, ln of b, and then I basically have to find the derivative of d over dx of b to the power x, plus the derivative of constant. You don't have to worry about this, it is derivative of constant is 0, right? Guys, from here we know that this is still going to be 1 over ln of b, and we know the derivative of b to the x. Again, you're expected to know all your rules for derivatives. So the derivative of b to the x is b to the x times ln of b. Guys, you can go back and look at the formula sheet or your textbook if you don't remember this, but you should try to remember those things. Now what happens here, ln b and ln b crosses out, you're left with bx, and that's what you have here on the left hand side. So this actually is also valid. And then the fourth one, which is sometimes kind of students find it tricky, but it's not too complicated. That is, guys, if you just have an integral of any constant with respect to x here, any constant. Guys, integral of any constant with respect to x is simply going to be the constant times an x plus a c. Okay, and I'm going to show you, it's not too difficult to actually convince ourselves why is this equal to this. One way is to just look at the right hand side, take the derivative, you will get it. That you can see easily and you can do it on your own. But the other way is just using the power rule. And you must be wondering, how can one use a power rule here? There's no x. Guys, you can rewrite this, and that is something that we have to be confident with, and we have to practice more and see examples where you sometimes have to rewrite things so that they look like the things that we know, and then go from there. So in this case, we may not be able to see directly that there's a possibility of using the power rule, but look here, guys. What we can do is we can rewrite this as b times x to the power 0. Because what is x to the power 0? X to the power 0 is 1, b times 1 is b. So I have not really changed this quantity, but I have just introduced something else that might help me to use the power rule here. And of course, there's still a dx. Don't forget about the dx. And guys, we know when we are multiplying a quantity by a constant and we're trying to find the integral, that's one of the basic properties. You just take out that constant outside the integral, okay? And we kind of do the same thing with the derivatives. Whenever x, or whenever a number, or whenever a variable is multiplied by a constant and you're trying to find the derivative, we just take that derivative outside and just find the derivative of the variable. Okay, same thing we do with the integrals. You just take the derivative, you just take the constant outside, and then you just have to evaluate the integral of x to the power 0 dx. guys, this x to the power 0 is a perfect candidate for power rule. We know power rule works for anything which is of the form x to the power n, except for n cannot be -1. N is not -1, it is 0, so it works for 0. So let's see how we can simplify this. So b stays outside, and when we use the power rule on this guy, I'm using the power rule on this guy, it's just going to be n plus 1, which is 0 plus 1, divided by 0 plus 1. Of course, there's a plus c. Then let us simplify this. 0 plus 1 is still 1, but we don't have to really write it. Downstairs, there's a 1. I don't have to really write it, so it's bx plus c. That is exactly what I'm trying to say here for the integral of a constant with respect to x. So guys, these are 4 basic ones. Then there's the integrals of trig functions as well. So you have to like look at the formula sheet or your textbooks, because when we start solving examples, I will be doing all these types that I have talked about here. Exponential functions, and we have the inverse function. We have the simple power rule for polynomial functions, for constants, and then we'll also be doing examples with the trig functions. Okay, so guys, this is some of the rules. There's more rules. Look at your textbooks or formula sheets for them, and then we will start doing examples based on these. Okay, till then guys, take care. I will see you in the next video.